Oh, I'm sorry. Sorry about that. I was just admiring this beautiful picture that we drew here. Actually, my sister drew this. My sister and my mom draw everything on the whiteboard for me. Anyway, don't you just love this picture? I thought it would be super appropriate for today because we're continuing on our section of interference. And we're going to continue to talk about how ham radio interferes with appliances like toasters, annoying your mom or your wife or whatever. And we're also going to talk about some other types of interference. In fact, there are 7 main things that we're going to be covering today, and I'll tell you what they are as we go along. So let's begin. And the first thing we're going to look at is types of interference. Types of interference. Now, the ham radio test will expect you to know some different types of interference that there are. And there are a few different terms, a few different things that can cause interference. There's fundamental overload. Fundamental overload, it is written on the board. Thank you, Lily. Fundamental overload is written here on the board. Fundamental overload. This basically means receiver overload, which is when your receiver gets overloaded with signals. There's also what we call harmonics and spurious emissions. And all those are just fancy words for saying interference. These are types of interference that the test will expect you to know about. These are all types of interference. They're all bad. That's bad. Okay, the second thing we're going to look at is interfering with AM and FM radios. When your ham radio interferes with normal AM and FM radios. So sometimes normal AM or FM radios, like the kind you use to listen to music, sometimes they accidentally receive ham radio signals. And you might be like, okay, how does that work? Because if you actually look at the AM and FM radios, they do not receive the same frequencies that ham radios transmit on. And yet, sometimes they pick up ham radio frequencies. So how exactly does this work? Well, sometimes the AM or FM radios receive ham radio signals by accident because their receivers aren't built very well and they can't reject strong signals, even ones that are outside the AM or FM band that they're supposed to receive on. So even signals in the ham radio band, they're so strong that the receiver just can't resist them. It can't reject them. They just barge in. This is a problem with the receiver, and it means the AM or FM receiver wasn't built very well. Okay, the third thing the test is going to ask you about. Number 3, interfering with telephones. Interfering with telephones. I almost want to say interfering with toasters. Unfortunately, there's not a question about toasters on the ham radio test. Anyway, interfering with telephones. So, oftentimes ham radio will interfere with your telephone. In fact, this happened a lot back in my grandfather's day. He was a ham radio operator. He is a ham radio operator, and he had problems where ham radio would sort of show up in his telephone. In other words, as you're talking on the telephone and someone's transmitting on ham radio, you can hear the person on ham radio in the telephone. So obviously this is a problem, and the RF radio frequency can get into your telephone wire, mess everything up. So what you do is, again, we talked about this yesterday, you put an RF filter, or in other words, a ferrite choke on the telephone cable. Remember, I talked about these. You can order them from China, and they'll include a little hair in your package. You can order that from Amazon. So you put the cable in here, you snap it on to the telephone cable, boom. Most of the time, that fixes your telephone interference. I don't know exactly how these work or why it works to snap this on, but somehow it chokes all the ham radio frequencies out of the cable. Okay, fourth thing you need to know is interference in regards to your ham radio equipment. So not like appliances like your toaster, but maybe interference to other items in your ham radio ham shack. So oftentimes on ham radio, you might be talking to someone and they might report that you have garbled or distorted or unintelligible transmissions or something, even though your signal might even be strong, but your signal might be garbled or distorted or unintelligible. And usually what this means is that you're experiencing RF feedback. Remember, RF is radio frequency. That means the radio waves you're transmitting. Feedback, RF feedback. RF feedback, the reason we call it feedback is because the signal you're transmitting, it sort of goes backwards, or maybe not backwards through the cable, but it goes back into your microphone cable oftentimes. The RF that you're transmitting, it goes out of your antenna and it goes into your microphone cable. And when that happens, it messes up all the signals going to and from your microphone. RF goes into your microphone and messes up your transmit audio. And this especially happens if your antenna is sitting really close to your radio, because then, it's easy for the radio signals. They're stronger, they're closer to the microphone cable, they'll go into the microphone cable more easily if you're right up to the antenna. If you move farther away from the antenna, oftentimes RF feedback will go away, because then instead of going in the microphone cable, the RF just goes everywhere out of the antenna, but it doesn't penetrate into the cable because it's too far away. So how exactly do we make sure that RF doesn't get into a cable this way? And not just a telephone cable, but really any cable. And again, one thing we talked about yesterday was these ferrite chokes, which are really great. But another way we can do this is using shielded wire. And the test might ask you about shielded wire. So shielded wire basically shields RF from entering and getting into the cable. So let's look at the sample question that the FCC has, or that they have about shielded wire. And it asks, which of the following is a common reason to use shielded wire? A, to decrease the resistance of DC power connections. B, to increase the current carrying capacity of the wire. C, to prevent coupling of unwanted signals to or from the wire. Or D, to couple the wire to other signals. This is an actual question, not actually from the FCC, since the FCC doesn't write the questions anymore, but it's a question you could run into on your technician class exam. And the answer is C. Now, answer C does sound a little technical. It says to prevent coupling of unwanted signals to or from the wire. Okay, so what exactly is coupling? Well, these hams, or whoever wrote this question, they're just being sort of nerdy and technical. This is the technical definition of really what we just said. It basically means shielded wire shields unwanted signals from entering the wire. It prevents coupling. That's the official or technical way to say that. Anyway, now you know the answer to this test question. So let's look at the fifth thing you need to know, the fifth out of the 7 things you need to know, rest of the things you need to know for this section and in this video lecture. So we've talked a lot about interfering with your own appliances, but what if you interfere with someone else's stuff in your neighborhood? Like, what if you interfere with your neighbor's toaster? I mean, that's even worse. If your neighbor's toaster starts blathering about, that's not good. So especially the test is concerned with your ham radio interfering with your neighbor's TV or their normal AM, FM radio. And if your neighbor comes up to you one day and says, you're interfering with my TV or my radio, then there's a few things that you should do. And specifically, you should make sure that your station is functioning okay. Since obviously if something's not working right with your station, that might be the cause of the interference, and you should fix that. But you should also check and see if your station causes interference to your TV or radio. In other words, turn your TV or radio on, transmit on your ham radio, and see if anything bad happens. That's what the FCC wants you to do. And that way you can tell if you're really the one causing interference. Now, I want to give you a little side note here, and this isn't going to be on the test, but I just want to let you know. When you first set up your ham radio antenna in your backyard and your neighbors are asking you, what is that? And you say it's ham radio, and they're like, oh, okay. Anyway, don't go around telling people, by the way, my ham radio, it might interfere with things, so if you have weird problems with your Wi-Fi network or whatever, maybe it's my ham radio, so just let me know and we can fix it. Don't say that if they haven't actually had problems yet. Because if you say that, if you say my ham radio might cause problems, then every time they have any little problem at all with their Wi-Fi network, anytime their Wi-Fi goes down, they're automatically going to blame you, and they're going to come knocking on your door and blame your station. And this will happen even when it's really not your fault. I mean, you know, your ham radio might not actually be interfering with Wi-Fi. My ham radio never interfered with our Wi-Fi. Maybe your neighbors just have bad Wi-Fi. But if you go around telling them my ham radio might interfere with stuff, let me know, then every time they have bad Wi-Fi, they're going to blame you even if it's not your fault. So don't go around telling people that you might interfere with them by accident. Don't go around telling people that. Anyway, the 6th thing that we have to cover today, getting rid of interference. Interference is bad. You've probably figured that out by now. How do we get rid of it? Again, ferrite chokes. These are very important. But there are a few other things we can use as well. There are various filters you can get for ham radio which filter out the interference. And especially the test will want you to know about, there's a lot of different kind of filters actually, and they all do the similar things. There's low pass filters, there's high pass filters, there's band reject filters, there's band pass filters, there's all kinds of different filters. Basically, all these filters can be used to eliminate interference. And you can look in your book, there's actually a test question asking about these, and it'll ask you how you get rid of interference. And the answer will be ferrite chokes and low pass filters, high pass filters, band reject filters, and band pass filters by those specific names. And I was going to write them on my board, but my sister's hand got tired. So anyway, you can check in your Gordon West manual, and you can read that question in the book, and you can get more familiar with these types of getting rid of interference and using these filters to get rid of interference. So there's another thing that the test might ask you about, and that's overload. We talked about overload a little at the beginning of the section when your receiver sort of gets overloaded or something gets overloaded with interference because of interference. Now, overload like this can be reduced or eliminated with filters like the ones we just talked about. What you do is you put the filters at the antenna input of the affected receiver. So in other words, if your satellite TV is experiencing interference from your ham radio, put a filter at the antenna input for the satellite TV, and hopefully that will filter out the interference before it goes into the satellite cable box, and your TV signal will be okay. All right, now let's look at the seventh and final thing we need to look at for interference before we go away, and I have to erase, sadly, this awesome picture on the board, and that's number 7, being interfered with. Being interfered with. In other words, when you're operating on the station and you're not interfering with the toaster, but maybe the toaster's interfering with you. Or maybe not the toaster, but you get the idea. So there's something you really need to know here that the test wants you to know about. This is the concept of a Part 15 device. Have you ever heard of an FCC Part 15 device, or FCC Part 15? You might have seen this before. If it sounds familiar, this is often printed at the back of television remotes. Go grab your TV remote right now if you want and look on the back, and you should probably see somewhere on the remote, usually on the back, little text maybe engraved into the remote. And it's very tiny, very easy to miss, but it's there. If you look at the back of your TV remote, you read this text, it will probably have some kind of warning saying it's a Part 15 device and it cannot cause interference and everything like that. You may have already noticed this, maybe you didn't. It's easy to miss. So a Part 15 device is basically an unlicensed device that transmits low-powered radio signals on frequencies that are usually used by normal licensed services like ham radio. So your remote, it doesn't transmit very powerfully, so it doesn't need a license. It's unlicensed. But because it doesn't transmit very powerfully, they decided they could let sometimes these remotes transmit on frequencies used by licensed services like ham radio. And as a result, sometimes these remotes and these other Part 15 devices, such as other types of remotes, like the kinds that power model cars, oftentimes these will transmit actually on ham radio frequencies, except they're so weak they usually don't cause problems. They're so weak they usually don't cause interference, and they're not supposed to cause interference either. Unfortunately, sometimes they do cause interference, occasionally. If something in your neighbor's house, say, does cause interference to your station, if there's a Part 15 device or something, maybe they have a remote control helicopter and it's causing interference to your ham radio station, you have priority. That device is not licensed. It's supposed to be weak enough where it doesn't interfere with you. If it is interfering with you, it's breaking the law and they're at fault. So there are 3 things, basically, that you should do. And I made an acronym for the 3 things you should do if your neighbor is interfering with you in this way on ham radio. WIC. WIC. Do the WIC. Work, inform, and check. Number 1, work. Work with your neighbor and try to figure out what's going on. Talk to him and try to figure out what's causing the interference and why the interference is happening. Number 2, inform. You should inform your neighbor very politely. Don't be rude. You don't want to start an argument or anything. But inform them that their Part 15 device is not allowed to cause interference. By FCC law, it cannot cause interference to your ham radio. And finally, check. Number 3, check. Check your station also. Check to make sure that your station is all right and that the problem is not on your end. Maybe your ham radio is accidentally picking up things that it shouldn't be picking up. Anyway, just check your station just to make sure that everything is properly in order.